So continuing our conversation about effective rate of interest, let's look at just a couple examples of sort of charts and sort of seeing the way that you can actually compare them. So consider how compounding periods affect the annual interest rate of the following. So if you see something that says 2.99 per year and compounded whatever. So if it's 2.99 compounding annually, then they're just equivalent to each other. But notice how if you change when they're compounded, how it increases the effective rate of interest. So obviously if you're compounding more frequently, say bi-weekly, you are getting a higher sort of idea of effective rate of interest. If you look at something which is a little bit higher of an interest rate, like a credit card for example, commonly credit cards are 19.99% per year. So you notice that if it's compounded annually, great, it's the same percentage. But as you increase your compounding times or your M value, you notice how we have this increase in value in our effective rate of interest. And a lot of the times, even credit cards are actually compounded daily, so that makes a difference. So let's do an example of calculating effective rate of interest in terms of a daily amount, which again is pretty common in terms of a credit card situation. So this is asking us to calculate the effective annual rate or effective rate of interest for a typical credit card, which states that the annual rate is 18.5% and interest is calculated daily. So we can go to our resource sheet and find the formula. So effective rate of interest is the following. So remember, there's two embedded brackets, so this one's extremely important to watch your order of operations. So we have EAR is equal to big bracket and smaller bracket 1 plus our I value to the exponent m minus 1. All of that is multiplied by 100 to get it into percentage form. So what's given in the question? We have our R value of 18.5, and we know we should write that as 0.185. And we have our M value compounded daily, so that's 365 times per year. Every day it's being compounded. And then we want to calculate our I value based on that, which is R divided by M, or in this case 0.185 all over 365. So let's substitute in our values into our formula and do our computation. So 1 plus I, 0.185 divided by 365 to the exponent 365 minus 1 times 100. So when you put this into your calculator, do your inside bracket first. So you want to do this value first. So 1 plus 0.185 divided by 365. Get that value, hit the exponent to the exponent 365, hit equals, get that value, minus 1, hit equals to get that value, multiplied by 100. And you should end up getting to 2 decimal places, approximately equal to 20.32%. So that's quite a difference. Looking at 18.5, you think you're getting a lower sort of interest rate, but it's calculated daily. So effective rate of interest, you're actually looking at 20.32%.